So in general, if you can repeat the same process or the same expression, same formula, you can derive each and every updater involved in hidden layer. It doesn't matter is it W or B. So in general, you can summarize in this way. So if you want to find the updater of W13, it should be alpha time delta 3 x1. So if you want to find updater of W23, it should be alpha time delta 3 x2. So you will find it's very common there. Okay, let's say I talk about the node 3 there. If you want to find, let's say this one, del E over, sorry, this one should be forget about the notation, this one should be x1. So del E over del W13, what you do is just multiply between the delta 3 with x1, multiply this one and this one, you get this one. Okay, multiply this one and this one. Okay, multiply with this one as one, you get this one. So of course, to find the updaters there, you need to multiply with alpha. So same, so you can see that there's a general patterns there. To find here del E over del W23, you must multiply between this one and this one. Multiply this one and this one, you get this one. So same, multiply this one with 1, you get del E over del B3, which is this one. Okay, again, this should be multiplied with 1. So I just remove that because it's multiplied with 1. You still get, you can delete this component. Okay. So again, the same thing happened at the node number 4. This is for node number 4. So then you can see that now we have very general pattern. To find the updater of W13, you need to know the delta 3 and the input. Okay, the delta 3 and the input value which is going through that line that you want to investigate it with it. I mean, if you want to find the gradient of this one, what are the input going to that line? It's a x1. So it's going towards where? It's going towards node 3. So node 3 means that's involved with, that is related to delta 3. So to find this component, must multiply this one and this one, then you get this one. To find this component, multiply this one and this one. So it's very common. It's also happened at the output layer that we have discussed before. Multiply between this one and this one, you get the gradient at that parameters. Okay. So again, I just summarize all this thing. What happened is actually during the fast forward, this is what you get. Okay. Again, remember that you're going into that direction during the forward pass. So that's why you process hidden layer first. Once you finish with all this destination, you get O3, O4. You get O3, O4. Then you bring that value here. Then you can process or proceed with this output layer before you can find the Y1 head and Y2 head there. Once you finish that, you try to calculate the total error. Now again, the back propagation is all about finding the gradients of each and every parameter, which is also known as a del E over del that parameter. It can be del E over del W or del E over del B. So if I draw it in backward pass, okay, that's why this is where I use the square now. So that's why I never use square before, because I want to represent square as my backward pass. You can see that the local error E5 there is defined as this one. The local error E6 is defined as this one. And then from this E5 to get delta 6, you must if you can see the expression there, you must multiply your E with your F there to get this one. Okay, let me go straight into if you can go back into what is definition of delta 5, what is delta 5. Okay, if you let me go through back to okay, you can see here delta 5 is actually a multiplication of E5 with the derivative of your activation function at net 5. So meanings that if you go back to that slide, the slide I will talk about back propagations. Okay, sorry. Okay, so you can see that there's one patterns there. To find this one is actually delta 5 is equal to your F apostrophe net 5 times your E5. Okay, this component is there, E5, this component is there. So in order to find this one, you must multiply this one and this one. Okay, this one have been proved during the previous slide. I think you can check the previous slide that I showed there during the when we want to derive the output layer during the backward fast there. So of course in general, still if you talk about the node 6, to find this one, you must multiply between this one and this one. So once you get value of this one and this one, okay, at the output layers there, okay, if you talk about the output layers, to find the del 35 or here doesn't matter, you want to find a del the updater of W35 or in other words, you want to know this one is actually you to find, again, this is the I already discussed before, to find del E over del W35, you are multiplying this one and there's a O3 over here. Okay, if you remember that this node will produce O3, this node will produce O4 during the forward pass. So to find this one, you must multiply this one with this one. To find the gradient happen at this one, you must multiply this one and this one. To find the gradient of this one, you must multiply this one with this one. To find the gradient of this one, you must multiply this one with this one. So means that you can see this general concept there. It depends on which arrow connected to which neurons there. Same goes to the bias there. To find this one, you must multiply this one with 1 here. To find gradient of this one, you must multiply this delta 5 with 1 over here. So now that is in general, that is how we compute each and every del E here. Okay, doesn't matter which neuron at the output layer, it can be generalized in that way. Of course, after you find the gradient, you must multiply with alpha to find the updaters here. How about the hidden layer? Okay, the hidden layers here, you can see that it's almost similar there. Okay, to find this one, you must to find the gradient of this one, you must multiply this one with this one. To find the gradient of this one, you must multiply this one with this one. And to find the gradient of this one, you must multiply this one with this one. And to find this one, you must multiply your local error here with this one. To find this one, you must multiply the local error E4 here with this function. So the step here is similar. You can see that the step is similar. Means that to find this one, you must multiply this one with this one. To find this one, you must multiply this one with this one. So same goes to the hidden layer. To find this one, you must multiply this one with this one. Okay, to find this delta 4, you must multiply E4 with F apostrophe net 4. But there's some different things between the input layer and the hidden layer. As you can see that, okay, for the output layer, to define the E4, E5 and E6, this is the expression. Okay, this is the expression. But to find E3 or E4, then it's not directly as what we express this here, because to find this E3, what is E3? Okay, what is E3? See, how can sorry, I draw to another the other slide there. You must draw that discussion over here. Over here, I have a draw to another slide there. You must draw at this slide. Means that is before this title. Okay, before this one, because I have draw, because in this slide there's a two slide similar. One I put here, another one I put after that. Okay, which is this one. But this one, when I discuss this one, it should be at this slide. Okay, just remember, don't draw at that slide, draw at this slide, which is before this slide. Okay, so if you remember, what is the definition of your E3? What is E3? Yep, E3 is actually multiplication of W35 delta 5 and W36 delta 6. So meaning that if you go back to of course later you must draw at this slide. I have already drawn to the other slide, which is the same picture as that before. Okay, this one. So E5 I'm sorry, E3 is equal to your W35 delta 5 plus W36 delta 6. So you can see that to find E3, you need to multiply your W with this one plus, okay, you can see the error there. Okay, there's a two arrow going towards E. Just remember that going towards E, which is this arrow is come from W35. So W35 times delta 5 plus W36 times delta 6 to get E3. Okay, same goes to the E4. To find the E4, you must multiply your W45 with delta 5 plus your W46 with delta 6. Means that to find this one multiply with this one plus this one, this one multiply with this one plus this one multiply with this one. To find E4, this one multiply this one plus this one multiply this one. So you can see that the expression there is depend on the arrow directions there. How actually we distribute the error from from the output, the final output towards to the input layers there. So just remember that everything is almost similar. It can be generalized. To find the delta, doesn't matter that delta is belong to neuron at the hidden layer or the output layer. The formula is similar, but the difference is just the local error. If you talk about the local error there, E5 and E6, which is happen at the output layer, the expression E5 is equal to this one, E6 is equal to this one. But to find the E3, you need to multiply between this one, W35 with delta 5, plus W36 multiply with delta 6. Okay, because of this arrow and this arrow going into that direction, so you have W35 delta 5, this one W36 delta 6. You plus together, then you get the E3. You get the E3 there. Okay, same go to the E4 there. To find the E4 is a summation of or this a multiplication, W45 multiply with delta 5 plus W46 multiply with delta 6. Once you get the error E3 or E4, then you can get a delta 3 or delta 4. Just multiply this one with this one to get this one. This one you multiply with this one to get this one. So that is the generalization of each and every component in backpropagation. As you can see that the one that different is just the E. Okay, E at the output layer is not similar as E at the hidden layer. Okay, E at the hidden layer is defined by the W of the arrow towards that E. Okay, at the backward pass direction, means that from here. Okay, you must see the pictures there. If this is going to that direction, this one is going to that direction, so means that to find this E4, you must multiply between W45 and W46 and so on. So but again, in order for you to find why this is where actually we managed to generalize everything there. Means that in each and every node during the backward pass, you have your component E there, you also have a component delta there. So why you need to find the E? Because once you find the E, you can find the delta by multiplying your E with the activation of with this F apostrophe. So once you find E over here, okay, once you find E over here, then you manage you multiply with this one, this F apostrophe, you get this delta. So if you want to find this delta, you must multiply between this one and this one. If you want to find this delta, you must to multiply this one with this one. But before you can get this one, you need to calculate this one by this expression. Again, this one to calculate is not similar to this one. You must, in hidden layer, you have their own formula. Means that to find the E, you must multiply this one and this one plus this one and this one. Okay, so then after that you can get all the updaters there by multiplying the gradient with the alpha. Okay, so so in general, this is how it's look like. Okay, means that at the forward pass, what you do to find the O, then you need to get the net. Of course, this net is just not confused because I just draw this one. Actually, the net should be here. So it should be the net is equal to the summation of your X and your W and so on. And then the O there, to get the O, you need to once you find the net, you go into this activation function, you get the O. Okay, but at the backward pass, it's almost similar patterns there. Okay, now it's look like the input is E, the output is delta. To find delta, you need to multiply your E with the apostrophe, or I'm sorry, the derivative of your activation function F there. So which is why you can see here the pattern is very obvious. There is a very general pattern then it's easy for you to plan how to develop the programming that can represent this back propagation. Doesn't matter is it a forward pass or backward pass, because now you have a very similar pattern. Doesn't matter which node you want to tackle. Okay, just the difference is that the definition of E, any E there, or the local errors there happen at the output layer. The definition is different from the definition is different from the error definition of error E there at the hidden layer, because the hidden layer you need to know the connections there. Where is the W? What is the W involved? And then you must multiply with the delta of the adjacent neurons there. Okay, that's the. I hope you clear about that. Okay.